Looks like we're live. Hello,
Yeah,
everyone.
welcome
Welcome.
everyone for this very last workshop of the series, number 8, Road
It's
to
been
Cloud.
8 weeks. Wow.
Yeah, we made it. It's a long way. It's a long way, and today it's all about moving everything we have done so far into the cloud. But today it's not only me and Eric. As usual, we do have the full team, the full crew behind us. David, Bettina, Jack, Aleksandr, and Erick RAMIREZ are here not only to host or answer your question either on Discord, YouTube chat, on the community, even email to get the special voucher. We will talk about the voucher today. But again, this is not only two people, it's the full team.
Yeah, they have the hard job. We just get to talk. They actually have to answer the questions, so
We are
they
just
get
moving
props.
it on screen, yes. All right, so I told you that this is the last stop. We will move the project into the cloud, and spoiler alert, we will use GKE, meaning Google Kubernetes Engine. All right, let's get rolling. But before starting, a word on certification voucher.
Yes, everyone has questions.
You keep asking about the voucher, and we keep saying, yeah, you will get all the info at the end of the series, and this is today. So early next week, you will receive an email with the link to claim your certification voucher. All right. So this is the form you have to fill. You must complete the form if you would like to receive the voucher. Remember, it will be sent next week.
Right.
Okay, I can totally see the question flowing on YouTube right now. All right, moving on. Housekeeping and setup, cloud computing, back to basis. Don't want to spend too much time, but we saw that we do have students with us, so let's do the full pieces. All right, the live stream, as usual, YouTube is the main one. We also stream on Twitch as a backup, but we don't really follow question there. We're answering live question both on YouTube and Discord. It's easier on Discord to have more follow-up. YouTube is going very fast. And for question during the week, you do have the forum DataStax community. If you have some issue, troubleshooting, putting a log, and get any help, community is there. This is also where you find all the homework during the series. I think we don't give you homework this week.
Yeah, last week.
Yeah, we are pretty nice for the last week. No homework. Okay. Astra.datasite.com. We will keep using Astra today to connect and use Cassandra. All the materials are again on GitHub, both slide and courses. And as I told you, the big things today is using Google Cloud. So during the first slide, you can make sure that you do have a Google Cloud account. Go to Google Cloud and create an account if you don't. All right, and let's get started with the traditional and regular Menti quiz.
Awesome. It looks like our screen might be frozen here. We can get this sorted out real
I'm
quick.
sharing the screen. I'm totally sharing my screen now.
Yeah.
Yes.
Everyone, we are experiencing some technical difficulties, but we'll be back.
Okay. Doing it right now. Tell me what you see.
It's
Okay. All right. Okay.
awesome.
So far, so good. We didn't share any special things, so that's
Yeah.
okay. But yeah,
Company secrets.
please interrupt me if I'm doing something the same thing again. Okay, so Menti, I'm waiting for the sum up, and you be ready to answer a question.
We're a little lighter this week on viewers, it looks like, about 270 in YouTube. So a little bit lighter than previous weeks, which makes sense. I mean, last week here. So why don't we give it till we have, what, say 130, 140 people thumbs up, then we'll go?
Yeah. Okay. I do have 80, about 80.
Yeah. Come on, a few more people. 90. Well, we might have to go without the whole 140 there.
All right, let's go. Okay, Menti, whenever you want. Hello, Menti. Okay, let me refresh Menti.
Today's going to be one of those days, right?
Yeah, but you know, after 8 weeks, we kind of prepare now. Don't we?
Yeah. Okay.
All right.
Ooh, 160. Awesome. All right.
All right. Okay, question number 1. And what is your progression in the workshop series? Yes, small technical difficulties in the beginning, as usual.
Man, a good portion of people have caught up by now. It was a much more even split between kind of weeks 5, 6, 7 and up to date, but we're a lot of people are getting it finished out. That's awesome.
Yeah, that's great. Awesome. And you all, and most people are also almost there, you know, almost 50 people started on July the 1st and working with the last weeks.
Right. That's wonderful.
All right, go to next question. What is your experience with cloud computing? Again, depending on this response, I will adapt my speech today.
Yes. Okay, that's pretty even across the board there.
Oh, yeah.
Although a lot of never use. That is interesting.
And also, I noticed less people have knowledge with GCP.
GCP, yeah. Which is interesting because GCP is probably, from an ease of use standpoint, one of the easier ones to get started with out there.
Yeah, but we will see later with the market share slide that, GCP is still number 3. So that will reflect the market share, I guess.
Very true, yeah.
So, okay, never used, about 50. Okay, this is really something I need to figure out because people could check multiple answers. So that's just a simple addition here. It just among almost 200 people, 25% never used any cloud. Okay. Have you ever worked with Google Cloud Console? So I expect 70%
a lot of no. Yeah. Yeah, and that's about what we'd expect. Absolutely, right there. I see a question in the chat there. Does today's workshop require funds on GCP? That's an excellent question. So, correct me if I'm wrong, Cedric. If you wanted to do the labs, there would be a small cost, not to us. We don't take anything, but from the GCP side of things. The labs today are all optional. We're not saying in order to go out and get a completed course or something like that, you have to pay money. That's not what we're saying at all. We don't.
Yeah, so it's not that simple. So indeed, so we will use GCP. Okay, first point. We will run Kubernetes in GCP, which is not free. It's about $1 a day, something like that. But when you create an account on GCP, you need to provide a billing account, but you won't be charged because Google Cloud Platform will give you $300 to use on their platform. So technically, yes, the service need as a cost, but because you join GCP, you will get the free credit. So you should be able to do the exercise without having any money being charged, but you still provide. You still need to provide a billing account, meaning a way to a credit card or something, even if it's not used.
I always forget that's the thing.
Yes, but the labs are not mandatory for today.
Awesome.
In 10 words or less, what can we improve? We do have a lot of answers already from the past weeks, but yeah, this is an opportunity. Today is the last week to help us improve. So
be brutal.
A few seconds. Oh, really brutal? Cedric, your accent is still awful. I got that before, yeah. Stop putting a French guy in front of the camera, man.
I like this one. You are perfect. Oh, yeah. Thanks.
All right. More free venture. They will come, and I will redo the slide. 1 more minute for you to answer.
More admin topics. Okay. Yeah. Good feedback.
Please start the lecture. Yeah. Let's do it. Yeah, it's already 15 minutes, I agree. So let's do it. Okay. So go back to the slide, and we saw some question on the chat coming from Venture. So early next week, you will receive an email, okay, with a link to claim your voucher. You must complete the form if you would like to receive the voucher. Simple as that. And the form will be sent next week. You don't have to do anything. You will get an email with a link to the form. Okay, let's do it. Let's move on. Okay, let's start with the lecture. All right, so today we will discuss about cloud computing. So cloud computing is not something magic. Is running your application or code or anything. It's just someone else's computer. Okay.
I thought we ran on water vapor, but oh well.
Yeah, so it's not a magic term. There are data centers out there providing all the resources for you to run your application. So it's on demand. Okay, so on demand availability of computer system resources, especially data storage, cloud storage, but also computing, and without direct active management by the user. Most of the time is web-based. You simply have a console to interact, some APIs, and sometimes some SSH when some machines have been provided, but you don't have to manage except on that. It's become popular in 2006 with the creation of AWS, and the first services was EC2 Elastic Cloud Computing, which still exists and still leading today, providing virtual machine in the cloud. All right, so why would you use the cloud? Okay, so principles, I told you, is on demand, it's self-service. You will do that later. You go to the console, you ask for a specific resource, and the cloud provider will spawn that resource for you. It's elastic, so the principle, if you need more power, the cloud provider, if you provide the proper specification, will make your application scale as you need, or scale out, or unscale if needed. And the neat thing is you pay as you go. Everything is measured, CPU, storage, network, and they will provide a very detailed bill for everything that you are using.
Yeah, that's actually an interesting one too, because I know back when I was a solutions architect, oftentimes when you're talking to someone saying, you need this many nodes, and they go, I need to buy all this hardware, that's really hard to get approved. But to say, hey, I need this many cloud boxes, and here's the cost per month, a lot of cost organizations are much happier with that sort of a model. And engineers can then get the resources they need to do their job. So it's kind of cool.
Yeah, very flexible. You ask only for what you need. Small boxes don't pay a lot for POC, POV, but when you go production and you want big machine, you can as well.
Mm-hmm.
And another principle is a broad network access. The cloud provider do have data center all around the world. And so your application could be available everywhere quite easily. And it's secure as well. But everything in the cloud is mutualized. The resources are sharing. Disk are sharing, network is sharing. Even if the cloud providers provide you some isolation, logical isolation, resources are still mutualized. That means when you deploy on a cloud, you are on hostile environment. You don't have control on the network. You don't have control on the disk. You don't have control on the CPU. So you must assume that those could fail.
Right.
And they will fail.
And it even adds another layer of kind of failure situations where, I mean, you can get noisy neighbors. Back a few years ago, it was much, much worse. They've done a lot to improve it. It still happens, though. But, you know, if the guy who's running a VM that's actually utilizing some of the same physical resources as you know, you're allotted or right kind of adjacent, it can actually affect your performance. So there's a lot of interesting problems around that. But every year it gets better and better and better, and they fix a lot of the issues that historically have kind of given cloud a more cautious sort of assessment. So
exactly. So cloud computing is a huge success. Okay, no suspense about that. And the main reason for me is cost savings. You know, that make it okay. And on top of it, you can have the security because as everybody using the same platform, those guys have to make the platform very secure.
Yes.
Be able to handle health data or even working for federal agencies. Those knows what it is when it comes to security, and they need to be very up to date. You know, there is a 0-day patch to make those guys on it. So it's flexible, easy for mobility. I told you they do have a broad network access. So from a mobile phone, you can access data center close to you. It's cool for disaster recovery. Well, that's also part of your design of your application. You also need to know what you are doing to avoid any disaster. Same for loss prevention. It's in the cloud, so if you are using higher level of services, we will see that those application server will be automatically updated for you, and some management is handled by the cloud providers. And anything that you are doing is measured in order to give you a proper bill, so you can also have insights about what you are using and when you are using.
Right. Awesome.
All right. So in the cloud, multiple deployment model. So the first public cloud. Okay, so use one of the biggest cloud provider out there: AWS, Google Cloud, Microsoft Azure, Alibaba, Oracle Cloud, IBM Cloud. I put you just a list, but there are a lot out there. You can have a private cloud. So somewhere at your company or by a third party, you install a cloud, operating system providing all the cloud features like Red Hat. Red Hat is pretty good to provide private cloud or Cloud Foundry package vendor like that. You can have hybrid cloud. Some of the solutions are installed on-premise on your data center, and some are in the cloud, and both communicate to each other. And if you don't want to be locked in one cloud provider, you can also go to the multi-cloud route, meaning your application is running not on a single public cloud, but multiple cloud. Can be multiple public cloud, private, public, any combination is possible.
So why would I want to be hybrid cloud real quick or multi-cloud? Is there a good reason to do that?
Oh, right. So hybrid cloud is first, easy to have. let's start with hybrid cloud. So for some data, you want the data to still be on your machine, on your server for security reason, low constraints. So part of the application should remain on your host, but other could run in the cloud because it will be cheapest or more flexible. And you build an application that have two PCs, one on premise, one in the cloud.
So like maybe GDRP type, restrictions being kind of hard to comply with on some cloud vendors. You could store some of that on a local data center, an actual physical, you hung up your boxes in a rack sort of data center.
True. And some older technology cannot really migrate easily to the cloud. It's less and less true. You can probably do anything in the cloud mostly now, but it was the case a few years before. When it comes to multi-cloud, well, you don't want to be locked in with a cloud vendor because this guy can raise his price like that, and you cannot really say anything. But also for some cloud provider are more advanced feature than another. Microsoft Azure is known to have advanced machine learning services. So if you start working on one cloud and want to use pieces of machine learning, you can have your app running on multi-cloud.
And I suppose that also comes with operational concerns, like if you don't want to get accidentally rebooted as a service or something like that, and you want to guarantee uptime, running on multiple providers could potentially offer you that durability.
True. There are also some less known kind of cloud. So community cloud, so like city or dedicated community providing some resources to build a cloud. Community cloud and distributed cloud, you install multiple data centers across the world, connect them as a dedicated, isolated cloud, again, for some special purpose. But yeah, let's be complete.
Awesome.
All right, so back to Cassandra now, and you may remember this slide from week number 1. Cassandra fit very well the cloud deployment, and one reason is you can install nodes and rings in any location. So geographical distribution using multiple regions of a cloud, or hybrid and multi-cloud, and have the very same data layer available in all your clouds. I also remember that you could choose one cloud or another depending also, of course, on the cost. It's not the choose.
Of course.
Say, for my batches, AWS is pretty expensive. For these tasks, I don't know. I will try another services.
Right.
Okay, moving on. So that was the cloud deployment. What about the cloud service model? So at the bottom, we do have, infrastructures as a service, API to abstract various low-level details of your network infrastructures, all about physical computing resources, disk, networking, security, virtual machine, really the hardware, infrastructure as a service.
Right. So when we were using those lab instances earlier that were cloud instances, that's what we were interacting with was infrastructure as a service, whereas like Astra, for example, would be completely on the other end of that. We'll talk about that here.
Yeah, exactly. Yeah, we provide you EC2 instances VMware in the cloud. That was totally yes. Okay. On top, cloud provider provides platform as a service or PaaS. So now not only they provide you the server, but also the software that run on the server to host your application, your code. So it's really application server. So you do have a web application. Those guys provide you, the node server in the JavaScript. You simply have to deploy your app, or the application server in the G2E world if you're working with Java, or any runtime needed for you to run your application. Okay. And the best, the easier to use is software as a service. So this time, everything in the cloud, everything is running and managed for you. You simply interact with the application using the web UI or API they provide you. The applications are accessible from various client device, thin client, but you don't have to worry about anything. It's managed for you. Maybe worry about the cost, right? It's based per use. All right. So if I provide you some samples for IaaS, of course, the three main cloud providers, AWS, Azure, and Google Cloud Platform, Alibaba, I always forget about Alibaba, which is huge as well, provide you virtual machines, rack space as well, okay? Some platform as a service, if you are a developer, you probably have already heard about Heroku. So it's hosting your application, and there is a free tier. So very useful if, like me, you are working on an open source project to deploy some demo and everything. It's free using Heroku. It's not the only one. There is Cloud Foundry, very, very famous. Google App Engine was one of the first, and Red Hat, again, OpenShift. The service of Amazon, I will talk about this one later. And when it comes to software as a service, the most famous is for sure Salesforce, a huge software as a service that make probably SaaS popular. They were one of the first to provide this model.
You almost can't go to a conference on cloud without them having a mega booth there too. They're always a dominating presence in this.
Yes, and they are running a conference like with almost 100,000 people, bigger than AWS conference. Yeah, in San Francisco last year. Dreamforce, they call that. It's just huge. But yeah, they deserve it. So Workday, a very famous tool to handling all the HR aspect of the company. Shopify, or of course DataStax, Astra, because why not?
We're putting our new service in with all of these veteran services. I love it.
Yeah, because why not? DataStax, you don't have to manage the Cassandra cluster now. It's done, and you only have the SQL and interface and services to interact with Cassandra. Okay, so this is the stack. Okay. Networking, storage, server, virtualization, operating system, middleware, runtime, data application. That's a lot. And the more you raise on the pyramid, the less you have to manage. Okay, so private cloud, you still have to do anything. Okay. Infrastructure as a service, as I told you, middleware, runtime, data, and application are still for you, but all the storage, networking, storage, server, VM are managed by the IaaS. The PaaS adding on top of that middleware and runtime and dedicated operating service, data and applications. Okay.
We got an interesting one here. GitHub, is it a SaaS or a PaaS?
Oh, you know what? For me, it's totally a SaaS because you interact with GitHub only with API, HTTP, or the CLI, and that's it. There is no real runtime. Now, apart Gitpod, which is coming more and more.
Right, that's kind of a whole different piece.
Yeah, you use Gitpod before, but GitHub it's still SaaS. You don't have to provide any running application. You simply provide code, static code.
And if you think about what it's kind of replacing from the old days, the SVN and all of those older version control software pieces, those were software you'd go out, you'd install, and then you'd use. So essentially, we're replacing that kind of on-prem legacy solution with a modern cloud solution. So yeah, totally is software as a service. I would agree entirely.
All right. All right. Moving on. Just give you an overview. There are thousands and thousands of brands in any SaaS, PaaS, or IaaS. It's not here meant to be read. It's simply that the market is huge and there is space for everyone, anyone. Now, if you want to start a business in the software industry, you should be ready to have a SaaS, I guess.
Yeah, absolutely. That's definitely where the world is moving, and it's moving there at a kind of shockingly fast rate. I think almost every major database vendor now has something in the cloud. It's just the way things are offered these days.
Yeah, true. All right, so I told you about PaaS, Platform as a Service, the cloud provider providing you the middleware and the runtime for you to deploy your app. Now, what if your app is already in containers? That means the cloud provider only have to give you a Docker engine and a Kubernetes engine to orchestrate the Docker, right? So a term that we encounter now is CaaS, Containers as a Service, and all the cloud providers now also work like that. I see less and less real path when you deploy the full working application in a cloud. You tend to use containers when you can.
So if you guys are missing how to containerize what we've been doing so far, the last, I think it wasn't last week, but the 2 weeks prior to that were all about containerizing your Cassandra and containerizing your application. So definitely go check those out if you're missing the how to do that. What we're doing today is we're taking containers and we're now putting them up in the cloud in the GKE service.
Yeah. Exactly. So really, both PaaS and CaaS are part of what we call computing in the cloud world. And either your application is a binary to be run somewhere and you use PaaS services, or your application has been already packaged as a Docker image and you will use CaaS. And this is quite relevant because if you can package your app as a container, as an image, you can totally fine-tune exactly how the app should run and have less surprise when you deploy the app in an external environment. So you can see that I left some blank space on the right of the screen because there is something beyond container as a service, and we will see what. I think it's not now, it's later. All right. So that's the landscape overview about what is cloud computing, what are the services. So now, what about the providers and services? So as you can tell, Amazon is huge, both on the growth and overall market. As you can see, Microsoft is still there. Google and Alibaba, third and fourth, Tencent. On the Asia Pacific region, Alibaba, Tencent are huge. We tend to have a perspective or Occidental, Europe, USA, but those clouds are also very, very big. And there are also some strong niche players, Salesforce, Oracle, Rackspace, IBM, I quote them. Okay, moving on. If I put that in cloud market revenue, look at the numbers. The cloud market is $75 billion, and only for the SaaS. That's just crazy. And you can see it keeps rising and rising and rising. That's
look at that. 1 year it went up almost over $10 million. Billion. I'm sorry, billion. I need you to do the $1 million.
Billions. Yes. And you see the market share. So again, Amazon, huge, Microsoft, Google, IBM, Alibaba, Salesforce, always the same names. One thing I noticed though is look at the path. The path is still smaller. So I feel that either people just only use IaaS and they do everything on their own, or SaaS and they want the cloud to completely manage. But with more and more Kubernetes and cloud native technology, more and more popular, I expect the PaaS part to grow, because for me, as the previous slide stated, CaaS is part of platform as a service. They provide you the Docker engine to run the Docker image.
Yeah, and I think this is actually an interesting graphic because I think it shows a correlation between using the as a service. So, for example, if we were to go out and use Astra, right, that's a SaaS application. We also need somewhere to host our application that it is utilizing Astra. So that would be obviously on the infrastructure as a service side. So when we deploy our app, we're actually going to utilize both SaaS and IaaS services.
Exactly. Again, I promise this is my last slide about graphics and market share. But here you can see the progression in 3-4 last year. And you can see how much AWS, Azure, GCP, and Alibaba made some progress. Okay, and the market for 2020 prediction AWS, more than half. That's huge. That's huge. So this is the reason why in the next slide, I will go a bit deeper in the 3 big here, AWS, Azure, and Google Cloud. Okay, so let's start with the biggest, AWS, and the first.
Bad old guy at the table.
All right, okay. So a cloud provider will first list you what they call the global infrastructures. They will tell you where are their data center, for legal and latency regions. And in each data center, each region, they will tell you how many availability zones they have. So because availability zones are multiple physical location or virtual location, the idea is if you lose one of the availability zone, you still have the other still up and you don't lose the full region. So when you deploy an application on a region, you make sure that if you are running a distributed system using multiple nodes, you will put your node in different availability zone to have the best availability time.
Right, latencies go down if you're doing that correctly for your applications.
Exactly. That for me, it's really for failover. So region is for latencies and legal region. Availability zone is really for failover.
True.
So as of now, it's pretty hard to count how many services Amazon Web Service has. New one pop up every day. But telling at the namespace, that is a names allocation in AWS Services, you can see the progression that, from 25, 7 years ago, to now 219.
That was, last year. Yeah, I see someone saying, slide is very old. Yeah, I believe this is a 2019 slide, and in that time, this has grown significantly.
Yeah, of course. And 2020 is not over, and we didn't yet have the big Amazon conference where they just announced 15 new stuff. So I feel fair to have, as of now. So if you connect to AWS Console, you do have 219 services as of July 2020, but yours is not finished, and it's already 40 more than last year.
Right.
And just the slide just changed because now they have even more regions. They're just changing all the time. Okay, for the 3 cloud provider, I will give you again region availability zone, just to compare, and also a map. But those are pretty close. Okay, 2.6 AWS 24 region 77 availability zone. I cannot list all the service in AWS, told you 219, but if you connect to AWS console, this is categories you can find. And within those categories, I will focus on what the main one, the first one you would need when you deploy your application in the cloud, and I will do the same for each cloud provider. So if I zoom in, the top 10 AWS service you should know, in my perspective. Okay, this is me selecting the service, but the one I use, the first I used. So for the compute, for the gas, we told you already about that. It's AWS Elastic Compute Cloud. It was the first one, EC2, virtual machine, and you provide CPU, RAM, and the scale, the sizing of your instance you like. If you want to go platform as a service, there were AWS Elastic Beanstalk, and in the platform as a service, you will have multiple supported languages, supported platform, supported way to package application. And this is why using containers is neat, because anything could run in a container. I saw a demo on Google Next, I think it was last year, where the advocate just put a Fortran 78 code in a container and put that in the cloud easily. Okay, FAS. I will go back to FAS a bit later, but now you can even deploy only a piece of code in the cloud, and this is called function as a service. In the AWS world, it's called Lambda.
Pretty crazy stuff you can do with that too. But
yeah, but as we come back later, I won't go fast here. Okay, next, for the container, Amazon Container Service, ECS, Kubernetes Service, EKS, and you probably have heard people conversation on the street, word on the street. Oh, how are you using EKS, AKS, or GKE? And you will understand exactly what it is.
Okay, and to be clear, what we're going to be using today on Google is Google's offering, competitive offering to EKS.
Exactly. All right. So for the storage, when you spawn a virtual machine, you need a hard disk drive. So you use EBS for block storage. Okay, elastic block storage. There are also some file system. I didn't put there. It's called EFS. And there is also that huge service at the Amazon Simple Storage Service where everybody put any files in there. It's like, it's an API, put anything, get anything, object storage. When it comes to networking, VPC, so virtual private network, this is an isolation of your own network to run your own app isolated from other. Route 53 is the DNS, so domain naming service to have proper URL. Remember when you used the training virtual machine, it was w111.datastaxtraining.com because we just created the registrar datastaxtraining.com.
It's interesting with VPC, there's actually a thing called VPC peering that if we wanted to do that whole multi-cloud setup, we'd actually basically set up VPCs on each of the providers and then we'd peer them. It's almost like a VPN or an old, what were they called? T1 lines back in the day, where you're actually kind of connecting up these different networks and making it into one big network. So just kind of a little bit of info you guys can take home with you.
Yeah, or MPLS line. Did you heard about that? Yeah, that's totally opening two networks, two isolated networks in two-way communication in a secure way. VPC peering, you need that if you want to do multi-cloud, indeed.
Yeah, absolutely.
Okay, last but not least, CloudFront is the CDN. So CDN, content domain name. Just forgot about the CDN, meaning having the static resources available very close from you. It's part of the global infrastructure of the cloud provider. You will, deploy images, HTML pages, CSS, JavaScript stuff in the CDN just to download them very, very quickly.
Right. I've even seen people use it for video and other assets for websites.
Already, when this is a new way also to deploy application. I read something about the Jam stack in the JavaScript world. Instead of rendering the page either at the client side or server side they just render the page once, in kind of static manner, having 90% of the page render in HTML, put that in CloudFront, and when finally you load the page, you get the HTML ready to go. You simply have to, replace only the values.
Right. Yeah, that's pretty cool.
Yeah, that's very fast. Okay, and so now you may ask the question, what if I want to deploy Cassandra on AWS? And what I would like you to realize is you have multiple routes. You can go full IaaS, only asking the cloud provider to give you virtual machine. You install, you download the distribution of Cassandra, you download everything, you do everything on your own. Each cloud provider also have a marketplace or some shared image already set up. So people have already downloaded the software for you and tune the software already. So it will gain you one step. In AWS world, it's called AMI. So MI for images, I guess. It's all about acronym.
It is. It gets so confusing too. The first time I got into this stuff, I was so overwhelmed. I had to, do an hour, take a break just to try to absorb.
Oh, yeah. Okay. For platform as a service, so there is no real runtime to run Cassandra, right? So when we talk about platform as a service, you can either use Amazon Marketplace. So there you will find some ready-to-go AMI image. But when you deploy the image, there is also a third-party company here ready to help you and doing all the maintenance for you. So it's kind of platform as a service because you're not really handling anymore the machine. You have delegated that to a third party.
Right.
DataStax is one of them, and the offer is called DMS for DataStax Managed Services, available in the 3 clouds.
Concierge managed software almost.
But we are not the only one. There are multiple people ready to help you doing Cassandra in the cloud. All right, when it comes to SaaS, software as a service, so first, using Astra, okay, we keep telling you that when you create an Astra instance, you can simply say, I want my nodes to be on AWS. And then it's from the Astra UI that will spawn anything you need on AWS. And to do that, we are using the EKS services. Or, let's be honest, Amazon also provided Cassandra managed service, which is called Amazon Keyspaces. Last but not least, you can go the container as a service way, and this time you will use our or any Cassandra Kubernetes operator to manage Cassandra in Kubernetes. So here the Kubernetes service is EKS for Elastic Kubernetes Services. And each time it will be the same. The CAS for the 3 cloud providers using CAS operator and the Kubernetes engine on the cloud.
I got a question here. So what's the difference between DataStax DMS and Astra? Pretty simply, Astra is a self-service, click what you want and go sort of deal. DMS is a little bit more managed. We actually have a team dedicated to DMS who it's much more of a kind of a white glove concierge sort of service that's handled by by Cassandra experts with actually more of a hands-on approach. Whereas the Astra is just a self-service, click and go, and you're basically good to go.
Yeah, exactly. So indeed, Astra is software as a service, all in the UI. DMS is really you ask the DataStax team to install the server on your VPC. So we connect to your environment.
Right.
Of course, it's secure. We cannot do anything. There is something called a bastion between you and the DataStax team. But the DataStax team will install Cassandra, set up Cassandra, and will give you access with user and passwords. But DataStax keep all the management of the Cassandra cluster. You don't have to do it on your own, but it's manual because it's done by a team.
Yeah, one more question here, and then we'll have to move on. But does Astra support DSE plus analytics or search? And then there's kind of another one that I think is more or less part of the same question, or is it just DSE core alone? That's an excellent question. It's basically a highly configured version of DSE core, more or less. There's some guardrails and there's some other components that make it Astra versus DSE. But from a function perspective, if you're sitting down and you're just going to go use it, think basically DSE core plus a little, guardrail and other stuff. But more stuff is always coming to Astra as well. They're developing tremendous amounts of features and content around it. So that's probably not always going to be the case. It'll probably have more functionality down the road. We just have to wait and see.
Yeah, so you've disclosed a little bit of Astra's secret sauce. Yeah, so because the DSE image are faster with the same hardware. But, because it's a software as a service, maybe tomorrow we will switch everybody to Cassandra 4.0 because it's fast enough, right, and nobody will notice. But you don't have to notice because it's ISO functional.
And that's what you want your software as a service to be. You don't want to have to know how the sausage was made. You just want to be able to, cook it up and eat it. That's.
Okay. I will remind this expression. I love you guys, all the proverb and expressions you have. Okay, I will go faster now. So second is Microsoft Azure. If you look at the global infrastructures, here it is. It's created 4 years later than AWS. It has 40 region and 50 availability zone. And this is me counting the dot on the screen because I didn't find any proper statistics. But here you can say that more region. And maybe this is the case because Microsoft was there before and had a lot of data center all across the world and location already. Microsoft is huge. Probably it was easier for them to set up data center in multiple regions.
Absolutely. I've actually seen a part of a documentary, I don't remember the name of it, a while ago, where they were talking about their conversion of old legacy data centers to Azure data centers. It's actually pretty fascinating. But.
Yeah, I'm not surprised because it's a lot of region in a small amount of time. So.
Right.
All right. Again, Azure has a huge number of services. Again, no list, so I just show you here what it looks like. Let's say about, 50. And if you click in there, you can find sub-services. So here you do have the full pictures. Again, see, you do have compute, storage, networking for the IaaS. And then platform as a service with, again, compute, but it's higher level compute. Now it's really hosting your application and executing the code or the binaries, whereas compute is really, simply the machine.
It's always icon overload with these, there's just so many there.
Yeah, so true. Yeah, that's kind of a game. If you go to the cloud provider's website, you see download our icons or download our way to design architectures. And that's kind of funny. They should find a standard, This is a compute unit and everybody should use this logo. Okay, so this is quite the same service list as before. So translated to Azure. So yes, it's called Azure Virtual Machine. PaaS, it's called Azure App Services. FaaS, Azure Function. So containers is Azure Kubernetes Service, AKS. Storage, disk storage block. Okay, so persistent disk for disk storage. And Azure Blob Storage. This is the same as S3, object storage, get and put anything in the cloud. And for networking, Azure CDN, Azure DNS, and for the virtual private network, they call that virtual network or VNet. And I find the name easy.
Yeah, I think you might have skipped their Cosmos DB, which is their
database purpose, just to give it to the latest. So in each cloud, you would find relational database, NoSQL database, and I feel like it's useful to mention here Cosmos DB, which provide interface, especially compatible with Cassandra, but only SQL facing, but under the hood, we don't know what it is.
It behaves a lot in just the tests I've seen. It seems to behave a lot like a document DB from back in the day, in some ways. But
exactly, and in Cosmo DB, you can have an interface for Mongo, interface for Cassandra, depending on how you set up the DB. But yeah, for the tests we have done, not all the features in Cassandra are available on Cosmo, due to the underlying architectures of Cosmos, like for instance UDT, I think, or UDF, one or the other.
It's like an 80% feature set. We actually got a question here. Is Cassandra on Cosmos DB good? There isn't actually Cassandra. There's a Cassandra API. So,
exactly. It's just customer-facing API. And so we cannot really, as DataStax, we can't really tell if it's good or not.
Right.
We simply said we noticed that UDF, UDT are not there, and we did also some pricing comparison. So we feel pretty confident about our own offering, but it's there, and that
there's
could
actually
be
a talk. Jonathan Ellis, one of the co-founders at DataStax, at Day-to-Day Texas, I think 2 years ago, I think it was, gave a talk on that exact subject. It was basically just the comparison. Why would you use one versus the other? Highly recommend you check it out if you're curious on that.
Okay, and how to deploy Cassandra in Azure? Yeah, again, IPaaS, SaaS, CAS. Use the VM, install the machine on your own, or use pre-built Cassandra image. Use the marketplace where you find a pre-built image and ask for a third party to manage the image. DataStax DMS is still there. When it comes to software as a service, Astra, on Azure, it's coming. So it's in beta. It's not public beta, I guess, but it's there. It's finalizing. We did that in a couple of weeks. So use Astra, spotting Azure, and Cosmo DB is there, but again, we have seen some limitation. You can do anything you like. It's a SQL compliant API, and this is only what they pretend. And to run the container as a service, you go to AKS, Azure Kubernetes Services. And here I find you a nice deployment of Cassandra architectures in AWS. Each time for people already know all that stuff, I find a proper nice, pretty complex schema for them to focus their attention.
We can hold on for a second there. It looks like our video has frozen. Looking at the chat, a number of people are experiencing that. I am also seeing that on my end, so we'll give that a...
Okay, so let me stop sharing and restart sharing.
All right, yeah, it looks like it's a YouTube issue. Refresh it, and it should work. I don't know if you can all hear my audio here, but a refresh did seem to work.
Okay, so we just confirmation that both streams are still up. Again, you saw the secret sauce, how we deliver those workshops.
And everyone's saying it's back, so we're good.
Okay, so now Google Cloud Platform, this is the one we will use. So 24 region, same as AWS, 73 availability region, that's just 4 less than AWS, created 2 years, so 2008. And as of now, there are 34 services distributed in compute, storage, big data, and machine learning. And if I have a closer look at that, you find again for compute Engine, Kubernetes, App Engine, PaaS, and Cloud Function for FaaS. Storage, you can go SQL, NoSQL, big data, data store, file store, dedicated technology for big data, and dedicated services for machine learning. And if I do the same, what are the top 10 GCP services you should know? For the IaaS, Compute Engine, for the PaaS, Application Engine, for the FaaS, Cloud Function, for the CaaS, Kubernetes Engine, so Google Kubernetes Engine, GKE, for the storage, persistent disk for the block storage, so attach hard disk drive to a machine you are creating. Google Cloud Storage, which is the equivalent of S3. And for the network, again, with the name is pretty accurate, Google Cloud DNS, Google Cloud CDN, and Google Cloud VPC. I like the name. And they have also a very famous service, Google BigQuery, to run analytics query on multiple data sources. I find it's very easy to use and very nice to draw some dashboards. So it's worth giving a look at this one.
Real quick, that video I mentioned a couple minutes ago, the Cosmos Cassandra video, we're going to post that in the YouTube chat here in just a second. David, can I get you to do that real quick? You seem to have the link, so.
Yeah. I'm thinking about those guys answering all questions, and each time we say, oh, there is a link somewhere, those guys have to run to find the link.
We can create work for them. Ooh, power.
All right, so how to deploy to GCP? YAS, PaaS, SaaS, CAS, same way, okay? But you know what? We are also deploying, Astra and GKE, and this is how we are doing that. When you ask for Astra database in GKE, this is how we are doing. GKE cluster, multiple zone. Remember, multiple availability zone in a region to have the best availability time. We have Cassandra, the sidecar, and the collector. You saw that during the workshop number 5 for this one. And on top of that, Astra provide a REST API, a GraphQL API, and the SQL console. But you all know about that already if you follow the series. All right. And I just put some square around GKE because this is the one what we are doing. Before closing, discussing about all the cloud providers, it was fair to just put back a slide about DataStax Astra. So Astra is software as a service available in all the cloud. And when we set up an instance for you in one of the cloud providers, we are using the CAS operator. So when we're telling you that the CAS operator is production ready, we are using it in production.
Yes, eating our own dog food.
All right. Okay, so before moving to hands-on, because it's already 1 hour and we do a lot of hands-on again today, an evolution of the containers. So you can either ship your application as a Docker image to have the cloud provider running the images, or you can simply also deploy some code, only function. And there are dedicated server in the cloud provider that will host the function for you and execute the function based on events. Events could be either a HTTP call, because those also provide API gateway. So the IDs have API gateway endpoint, providing a URL and execute a function. But you know what? If you are not building the Docker image and running the Docker image, that means they're doing that for you. So if you deploy a Lambda function, serverless or FAS, okay, at the cloud provider, they will ship your FAS in a container and make that scale out if they need to.
Right, because they got to keep it all isolated too from all the other things they're running. There's a lot of concerns around security and data governance there that they have to respect as well. So
yeah, and when we say an application is cloud native, so first way to go cloud native is all based and shipped in containers, and now you know what, because PaaS have been moved to CAS. The other way now is to go fully serverless, and instead of shipping the app or the service runtime, you ship only the function, and you expect those cloud providers to run it for you. So it's available in public cloud providers, Lambda Google Functions and Azure Function. I already listed that before, but there are also some standard like FN, OpenWinsk or serverless So now there is a specification for if you want to run serverless also on your machines. All right. Okay. So why I just spend a few minutes on serverless is because when you are using the driver, there are some things to be aware of. So remember, the purpose of Lambda function, the Lambda function will be instantiate and execute only when needed. And this is why the cloud provider told you that the cost is lower. But with a database driver, and especially the DataStax drivers, we need to have the connection stateful. We do not want to reconnect to Cassandra each time the Lambda function is executed. You will lose time. So to avoid that, you want to have controls of the connection to your database. So when you set up a function, you can specify how many concurrent clients you can have on your database. So be aware of the number of clients connection to your database. Create the connection outside of the function entry point. This is called a call start. If you start doing Lambda function, you will see that there is a call start, a part of the function executed only when the Lambda is executed, not each time at the entry point. And this is a way to reuse the stateful connection provided by the drivers. Okay, so again, consider the correct characteristic compared to the function and runtime. Reduce startup time by disabling driver metadata and pulling warm-up. So that's pretty advanced drivers features. Disable driver habits that ping idle connection. So it's all about, okay, shutting down drivers feature that keep, asking stuff to the driver, to the DataStax, to the Cassandra database, just not to trigger the function each time for no execution. And move the data access and business logic away from the function entry point. Delegate.
Right.
Okay. Okay, that was my small speech on serverless. Again, go with your questions on community. We do have samples for each one of those. But not today. There is moving your application to the cloud. And you know what? We spent 3 weeks to package the application as Docker containers. Let's use them.
Absolutely.
All right. So now let's deploy our application on GKE part 1, exercise 1. So this is, remember, this is the logical architectures of our application. So we do have the UI written in Python, okay, React.js. And we do have two backends, one in Python, one in Java. Okay, same features, but two languages for you to apprehend the drivers. And we made some flags, feature flags, 2 weeks ago to be able to use either Astra or Cassandra using Cass operator. So spoiler alert, today we will put the flag to use Astra equals true. We won't deploy any Cassandra cluster in GKE. We will use Astra. So today is really deploying the application. Okay, so now let's go to exercise 1. So exercise 1 is really me doing the exercise in front of you with my GKE account. Again, this is optional. You don't have to do it or validate to validate the series or anything. But we really wanted you to go to the end and show you how to deploy. But if you do have the GKE account and the BD account, you have everything in the README to do the exercise with me. So let me switch to my UI. Google Cloud, home. Okay, that's me. And the README, Cassandra Workshops. Oh, we see you, Eric. Let me hide you. Okay. And okay, 8 weeks. Weeks 8. All right, and go to prerequisite. So prerequisite is having a GCP account. and create a project, okay, and do some billing. So what I did already is I went to here, and I simply created. You know, this is my workshop 8-week project, but I can go here and create a new project. Okay.
Oh, it looks like we might need you to reshare your screen one more time. The slideshow appears to have paused again.
Go for it. Tell me, are we back?
Give me like I think we're on like a 7-second lag between what I see and what you do. Okay. So give me a moment here. All right. It looks like it might be refreshing, and I can see the console. Perfect.
All right. You know, this is also the reason why we are two heads.
Yeah.
You know, it's not easy to have an eyes on anything. So I create a project here, sample project. Okay. And I can go to billing. Okay. And for my project, I will create billing. You know, it's all written. So for the billing, I will create a billing bucket, and I will set up a billing export to go in the billing bucket. And the ID is ready to have a CSV file explaining where do your costs go. Okay, that's the optional prerequisite. Okay, I did it for my project. If I go back to the list of projects I have, if I go to workshop 8-week existing project, and I go to billing, I've already created a bucket and defined the exporting info. And as you can see, I'm using the free credit provided by GCP. So even if I provided a billing account, I'm not charged. I'm simply using the credit here. Okay, so I've created a billing bucket, and if I go to file export, you can see that billing export is enabled, and I will export my billing to a bucket named workshop billing test. Okay, that's really the
how you keep track of your money.
Yeah, exactly. Keep tracking, as you can see, 0, 0, 0, 0. So it's cheap. It's just a demo. And with the report, you can say, how many days do we need to prepare the workshop for you? Okay. And I did that. Now let's do and create a project. Okay, no. I simply do the prerequisite. Now, as a setup, I need to go to Kubernetes engine. Let me go here, create your Google Kubernetes engine. Okay, so here I'm using the sandwich on the left part. Here are all the services provided by Google Cloud Platform, and I will go to right Kubernetes engine and clusters. Okay, here I do have 2 clusters ready, but here this is how I can create a cluster. Okay, I can either create a cluster and define everything on my own, so it can, take sometimes, or I can go to my first cluster, and this is why we recommend just to have a small cluster only for test purpose, which are cheaper. So if I go here and say create now, I can just wait, and my first cluster 2 is running. Oh, what it is? Yeah, I don't know why it is not happy. Let's see. Anyway, do I reach? Okay, let me do that again. What is the issue? Oh, insufficient region quota to satisfy your request. In use address. Oh, I already used my quota. That's good to know. We'll learn everywhere, every day. So I do have 2 clusters, I had a quota. So I can either remove everything or just show you my cluster running. Let's go with the cluster running. Okay.
Cooking show approach.
Yeah. Okay. So this is my cluster and it's running. So
can
when
you
do have
expand the window at all, just so the text is a little larger?
Okay, let me try that. What about now?
That's much better. Yeah, thank you.
Okay, so once the cluster has been created, you go to connect and you will go to run in Cloud Shell. And now that's really the interesting part. Provisioning your Google Cloud Shell machine, establishing connection to Google. Okay, and as you can see, the gcloud container cluster command has been done for me. And now I can start using kubectl. So kubectl get pods. Or get nodes maybe first. So it told me I do have 3 nodes. So let's see. Okay, I do have 3 nodes ready. And there is a way -o wide. We didn't use the command before, just to get more info about the nodes. And one thing to notice is nodes. So we used to call that workers in the previous workshop, have internal IP and external IP. So if you want this application to be available on internet, we would have some work to do with the network. Okay, and now I think I'm okay and I can go and see the command we do have here. Okay, so I did the get nodes and I did the get nodes -o wide. All right. Now, what we want to do is to execute a Docker image. This is all about Kubernetes. So we can either use some image we have defined for you. So this is the solution of the exercise from the previous week that we package as Docker image and push in the Docker registry. So here you can see updocker.com/use/DataStax devs. You will see I'm using the Bettina, member of the team, Docker account, and not these images because I've built this one and Bettina have deployed this one and I will reuse, but those are the same.
That is one thing we never showed, actually, was deploying this image out to Docker Hub. That would maybe be some content for a future time.
Yeah, so 3 commands. Docker login, user password, okay.
Right.
Docker build, okay, you do have your image, and Docker push, and you're done.
Fair enough.
Docker push --tag, provide the proper tag, here is latest. But you can give the name like that. Yeah, that's easier as that. Easy as that. Okay, so now we do have the image in the Docker registry out there, and we want to use them. So first, I will create a config map. Okay, so the config map look like this. So if I go ls.l, I do have all the files already to speed up the demo just to fit the 2 hours. But here, if I want to open editor, so look at that. Okay, expected. I will open a new terminal and I will go back to here. Okay. So let me wait. Okay, so open editor will open me this and all the files that
Can you zoom in on this one too? Sorry, it's just again a bit small.
Okay, let's do it again.
Much better, perfect.
Yeah. So the first thing I was asked is to create the config map. Okay, so if I go to the config map, okay, so config map, remember the Kubernetes workshop is all about providing environment variables to your running containers. So we will use Astra, okay, and the base address, again, remember this is the variable, the UI used to connect to the backend. Okay, so at first, we don't know what is the URL of the backend. So we could define base URL is empty. So, okay, so we simply define this. Then we created a YAML file to deploy only the backend. So see, it's kind pod. We only deploy a pod, and we are using the images from the backend. This one is a Python, okay? Alex, if you hear me, we would need that to change to week 8-Python backend, for instance, or -Java backend at some point. Okay, so the container is listening on 5,000. We didn't change the containers from last week, and we define dependencies between the config map and the containers using config map ref like that. And now I can create the namespace, apply the config map, and apply the backend. And now if I get pods, I should have my backend running. But if I do kubectl-n my app get pods, I will have a bit more because I already have the UI running. But what I want that to do is having the backend running. Okay.
And that looks exactly like what we had pretty much in the when we were setting this up in kind on our own boxes.
You know, this is why Kubernetes is called the operating system of the cloud. You should find quite the same environment each time. You know, the Docker image, the Docker image. Hopefully, it will run exactly the same in any Kubernetes engine, at least for the core features.
Yeah, absolutely. Can we expand the shell text? I'm sorry, I keep sounding like a broken record here. Expand this, expand that, but
you know, now I do have 2 letters per screen. But hey, that's okay. And you know what? The cloud shell is really what we need. Okay, so awesome. I do kubectl-n my app, and I do have at least Astra backend running. So if I go back just to show you. So first thing we do is create a cluster. So either it's called my first cluster 1 or exercise 1. 3 nodes have been provided. Each node has internal IP and external IP. I told you that. And also each node or worker has a dedicated name, GKE, the name of the cluster, and some code. Okay. We define the config map. We define the pod to have the backend. We created the namespace, and we deployed the 3 file. So this is what we did. We created the config map of config in the namespace my app. We deployed a pod called Astra backend exposing port 5000. And to have this pod running, we have pulled the image from DataStax dev CWS week 8 backend. So look like Alex went everywhere, changing from Bettina, DataStax dev. Good job. All right, so moving on. As you can see, nobody can access this pod because not only is the firewall is not open at GKE level, nothing is open at Kubernetes cluster, and nothing is open at the worker level. So we have to fix that. If you go back to the instruction, what we will create is something called a node port that will expose a port at the node level, okay, the worker level, mapping from internal pod to the node, okay? So
now a node port, just to be clear, I couldn't go on my laptop then and hit that port. It's only going to be available to other resources within Kubernetes. Is that correct?
Yeah, that's correct. It's still within, I can show you just after that. Here it is. It's still within the Kubernetes cluster. I will use a node port backend to expose 5000 as 30355. Okay?
Right.
And so,
real quick then, for anyone who's wondering how you'd then expose something to the outside world, there's something called an ingress, which I don't think we're setting up today, but that would be the proper way to do that.
The way to do what? Sorry.
I'm sorry. Expose a port if we wanted to expose this to the outside world entirely. But,
oh yeah, true. And we will see in a minute that is not the best way to do it, because you have to know the name of the node that hosts your pod to be able to do the node pod backend. So it's not, it's not dynamic. So let's see. So we create the node port and we apply the node port backend. And now if I go there, the node port backend has been, it's created. I don't redo the command because I already did them. But what I want to show you is next. Now, Astra backend, which is the pod, we need to know on which node is running. So we need to do that first. Okay, here it is. So Astra backend is running on a node ending with CO2 and CON2, okay? And we really need the IP of this guy now. Okay, so I go to get nodes. And if I look for CON2, this guy, the IP, -o wide, otherwise there is no IP, of course. CON2, the external IP is 35266.34211, okay? So this is the external IP here, okay? So we expose indeed the port 5000 to this guy, but we didn't open to the internet yet. And to open to the internet, you need to run a Google Cloud Platform command, not a Google.
Not to interrupt you again, but it looks like we are frozen on the presentation side again.
I am on the presentation.
Right. Can you reshare your screen quick though? It would.
Let's do it again. All right. Stop sharing. Start sharing. Start sharing. Okay. Waiting for your top. Are we back? Can we see the slide?
I'll know in just a moment here.
That's the weird behavior coming from Skype. Okay. Thank you.
Awesome.
Okay, so moving on. The node port export, the external IP is this guy, but I cannot reach the external IP from the external world because I did not open the the firewall from Google platform. So if I go to the README, this is what I've been asked to do. G-Cloud compute, firewall rules, create, and I want to open 30355. So now if I hit that, I should be able to access this guy. So if I go here and go exercise 1 backend, remember 35266342211. Now I have opened the port and I can access the Astra backend from any browsers. Okay, browser. Okay, I do have my IP and the way to access the API. So remember /API. This is where all the REST resources are. So I will update base address. So as you can see here, this is what I did already in the config map. It has the proper.
Yeah, we're having the same issue on my end as well here. We're frozen again.
So I cannot change screen, right? If I change screen, Skype is cool.
It seems like if you change screens too fast, something freezes up. Because on my end, I see you changing screens, but then on the YouTube end, we just get stuck.
Okay. Okay. Let me do that again. So stop sharing and start sharing. Yeah, it's share screen. And now I cannot share anymore. Yes, I think I just. Okay, now I'm stuck. I cannot share my screen.
Uh-oh.
Yeah, definitive Skype issue. No, I cannot share. again, the same issue from screen share. So let me, what could be the issue now?
I wonder if it would be worth taking a 5-minute intermission and we can just...
Yeah, for people to see if they can catch up. But
yeah, and then that'll give us an opportunity to kind of kill things on our end, restart it, and hopefully get in a good state. Sounds good to me. It looks like Cedric froze. Let's, we just lost Cedric.
Cedric will join us very soon. He is rejoining the meeting. Sorry everyone, there is some issue with the call.
Bound to happen sooner or later. I'm sorry. It's about 5 minutes and we'll be back.
Okay,
feel free to kill
5-minute break.
Hopefully we're back online. Can you all see us all right? Right. Like I've got about a 10-second lag here, so we are going to... Oh, did he freeze again? No!
I'm back. Can you hear me?
Yeah.
Okay, everything come back.
No tool repair, Cedric. That's pretty good.
Yeah.
All right. Should be seeing him momentarily. Is he back? Yes, they're back. They're back. Cedric is back. Awesome.
All right.
All right.
Okay, I'm back. Cool. So let's go on. So we have open, translate the port 5000 to 3055, and then we open with test node port, the port to be able to access the backend. Which screen? Yes, I do. Okay. No, that's okay. Everybody freak out. No, that's okay now. I'm only showing slide. Okay, so everything that we do for the backend, we do the same for UI. So we will create a pod for the UI. Okay, we apply the pod. Then we will create a node port for the UI, export 30333, and export as the firewall. Okay,
Real quick question, not to take up too much time, but why didn't we just forward port 3000 to 3000? Why did we use the 30,000? Was there a reason for that, or?
I think they are reserved for, and we tend to use 5-digit when it comes to COOP, but I'm not sure.
Yeah, that's fair. Just a curiosity point. All right.
But yeah, I could take the point later. Okay, so I touch UI. I've created a Astra UI pod, okay, referencing the same config map where we provided the backend URL. We apply the UI. We expect the UI to run. So as you can see now, I do not switch screen anymore. Let's be kind with Skype. Okay, so I want my namespace, my app, and I want the pods, and I want everything come from my pod, my app. Yeah, get pods.
Ah, yes.
Okay. You are seeing slide, but it's the same. Okay, it's the same. Tell me when you catch
the
up.
load terminal, yeah.
Anything that you are seeing now are a single browser, and I'm only switching tab from the presentation to Google Cloud Engine. So that's really weird to me. But okay, let's go slide mode. I do have really step-by-step to explain how to do so. So
Yeah,
can you see my screen on slide 49 now?
It is looking like it's actually an old slide as well. So we froze a while back. Yeah. For those of you who are interested, sorry for all the technical difficulties. We will be providing access to slideshows and everything for you, so you will be able to go through the slides later. Obviously, it's our preference to run through everything on screen here, but there just seem to be some technical difficulties on our end.
Are we back on 49?
Yeah, it's still 47. I wonder if would be potentially better. Alex, do we have the capability for that?
No.
Not really? Okay, that's fair.
Okay, another last time stop sharing, and I will keep using slide, and that's it. Okay, so what about now? Tell me that I'm on slide 49. And I will go full screen, and I won't move.
It looks like it is catching up slowly, potentially.
Am I full screen now?
You are, yes.
All right, okay, so moving on. Anyway, with all that, we got some delayed. Once we have defined the node port for the UI, you can access the UI with the URL provided, and giving user password and secure clone bundle, you can test your application. And as you can see, like you should see, you have the UI talking to the backend. But using a node port is not the best, because we need to know on which node is running the pod. So to avoid that, we are using, let's move on. We are using something, so this is the configuration we add. We are using something called a replica set and services instead of node port. So let's see how it goes. So in the Kubernetes world, there are other networking primitive, either that's simply exposing net port. You can use services, remember a name abstraction for pod, endpoint network policy, but we will use services here. Okay. Exercise 2. Okay, let's do the exercise 2. So if you look at the README, I'm afraid if I go to the README, I will screw it again. You will see that you define a YAML file, which is a deployment. So now it's no more a pod, it's a deployment. We are still defining which container we want to use, which Docker image we want to use, but now we are defining something, a replica set. Replica set means I want X number of pod running, and I don't care on which node it is. It's all related to the Kubernetes control plane. Okay, so I define backend config. It's quite the same. I simply do not provide backend URL, and I create deployment and replica set. And if I apply this, this is what it looks like. And you know what? We don't know where are the pods. We put some size equal 1, so we do have a single pod, but if you update size to 2, you will have 2 pods, and this is how you do scale out of a stateless application using called a replica set. And now we don't care on which node it's running. And so this is everything that has been created, the deploy, the result set, multiple pod. I will try in the end to go to the Google Cloud just to show you that. But once the deployment has been applied, you can see in the Kubernetes Engine UI, you do have a workload, and you can expose the port, it's 3000 to external, and creating the services and opening the route to outside GCP will be done automatically, or only for Google Cloud Platform will do that for you on all the steps, creating the service, exposing the service, creating the firewall rules. With that, you can just go there and click the link they provide you, and you can access the backend. Now that you understand what we did for the backend, we do exactly the same for the front end. So this chain, this process is the backend. This chain is the front end. And if I expose port, I will create an Astra UI service, and I can access the same, the URL provided in the GK UI, and again, I can access the database. So let's see. Let's try. Okay, will you? I go to the cloud, Google Cloud Console. I am still there.
Let's see if it pops up here. Give it 2 seconds. I'm just watching this stream to make sure it comes up. Yep.
Oh, no, that's just amazing. Okay, and still full screen?
Still full screen, yep.
Okay, so this is when I go full screen and exit full screen that we lost something. Okay, anyway, so moving on. I cannot show, I will move on. Okay, let's use it once again. Oh no, I'm pretty sure if I stop sharing, I will just screw up. So I'm still full screen, showing me happiness again, right?
No, it's actually not current. It froze on a previous slide, so we will need to probably reshare.
Okay, let's try again. So we figured that that's coming from Skype, but not sure why. Okay, can you see the GKE now?
Looking.
Mm-hmm. Oh, cool.
Yes,
Finally.
yes.
Okay.
Here we go.
So, okay, it finally appeared. So in exercise 2, okay, go there. Okay, be happy with me. If I go to the workloads, hopefully it's still there. As you can see, in my first cluster, I had one pod, a second pod, UI and backend. Now, exercise 2 is no more a pod, is a deployment. And if I go to the deployment, let's see deployment for the backend. Okay. The idea was there to expose. There were a button here to click expose. I expose, and then now my GKE created Astra backend services and provide me some URL I can invoke. Should I try to open a new tab? Let's see.
You want to live dangerous?
Point, at this point, how does it look like?
I'll know there.
Okay. All right. So that's weird. All right. So by simply exposing, now we do have a URL to expose the backend. If I go back to workload and doing the same for Astra UI deployment, and I go to expose, now is giving me a UI I can invoke. Warning, you have been redirected. Of course I am. And this guy should download the UI. It's all JavaScript, could take a few seconds. And I should have my UI ready to call my backend. Okay. The only pieces I'm missing during my talk without reading the README was once the backend has been exposed as a service, I do a URL, I need to provide the URL in base URL config map. That's still the same way to deploy. But when it's done,
It's spinning for a little while there. There it goes.
I should be able to do users. You are using Clear Video to do. Okay, and providing the secure cloud connect bundle, this one, and test connection. And so it will again take a while because I'm invoking the backend and the backend invoking Astra. And now I do have both UI and backend running in Kubernetes in Google Cloud.
That's the same thing we've run in all the previous weeks with
Exactly.
the Secure Connect bundle and all of that. So there's nothing crazy special going on there. If you want to see how to do that, just I believe it's week 2, I think.
Mm-hmm. Week 5 for Cassandra and week 6 for the application in Kubernetes. But here you can see in configuration UI config, I have defined the base address here. And I can edit the config map, reapply the config map, and reapply the pod if I want to. Okay, do we leave? Okay, let me see. Can you still steam? Can you see MENTI? Let's try to do MENTI, okay?
Try to do it. Yeah, we'll see. Ooh.
Okay,
yeah.
So, well, we finally... yeah, so let's try to do MENTI. The issue is not MENTI, the issue is my screen sharing. So as long as the MENTI is running, let's do it.
And people are very eager to connect, it would seem. That number is going up very quickly.
Yeah, sorry for the technical issue, that happened. Maybe tomorrow morning, Bettina will have more, and Alex will have more luck than me to redo the demo. But hey, you have everything you need to do the demo on your own. Okay, that's bumpy. Okay, I will press enter to start the countdown. 3, 2, 1. Okay, fast answer, get more points. Using Google Cloud is 100% free. Speed question. Actually, I have no reason. Is it expected? Time's up. Oh, okay. Finally.
Right. That is correct. You have to use your credits. So,
yeah.
And once the credits run out, then you would have to pay money. But today, it shouldn't go through any significant portion of your credits.
Exactly. Google Cloud is not free. It's simply that you do have some credits. Okay, next question. Leaderboard. Okay, who was the winner? 983 is pretty fast. Intruders. Okay, so we have an intruders. Brand the broken. Yeah, no surprise that you get the crown, the crown icon. If you get the reference. Okay, Apache Cassandra can be deployed on-premise only, on one cloud providers, on any combination of cloud providers and on-premise, in space. Space is so cool.
We need to get Cassandra running like on the International Space Station or something. That'd be awesome.
Okay, next SpaceX mission.
Yeah.
Yeah, most of you got it right. Okay, on
awesome.
Any combination of on-premise and cloud. True. Okay, leaderboard.
Ooh.
Brian is not broken. It's leading.
Oh.
Okay, and CKC and Gunks. All right. Next question. DataStax Astra is not compatible with the GKE. Is not compatible.
This one I hope everyone gets right.
Phew. Boom. Indeed. There was a trap. And I did not show you, but in Google Cloud Platform, if you browse the service, DataStax Astra is there. You can totally spawn a DataStax instance from the Google Cloud console. I did not do because we do have our own DataStax Astra instance for Wix, but it could have been the case. Leaderboard, CKC guns, oh la la, okay. AWS, that's funny. All right, Macy takes the lead. Okay.
Wow, that was quite the upset there.
1 point, only 2 points from the first to the third. That's what?
Like a couple milliseconds.
Exactly, 10 milliseconds. To find the external IP of Kubernetes node you use. Oh, kubectl get pods that -o external IP, Kubernetes get node -o wide, kubectl get node -o address, kubectl get node. Oh yeah, cool. What that?
Oh man.
David, are you there? Yeah.
Yeah, it looks like the screen might be frozen. So if you watch your phones, you will see what you need to see to know
Exactly.
who's getting what.
Yeah,
So just keep an eye on your phones.
Yes, we are showing the list of the board. Yeah, but we will do the MENTI to the end.
Yes.
Okay,
right.
Macy.
We're back in the running there. Bran moved back
Macy
out.
is first, Bran the Broken is second, Britannia is third. Next question is, in order to access an application deployed with GKE externally, you must add an entry to the allowed.list file, do nothing, this is allowed by default, create a firewall rule, bribe the local GKE custom agent. Okay, this one.
That seems like the right answer.
Yeah. Indeed. Create a firewall rules, and this is what I did when I execute or show you the G Cloud Compute allow firewall. All right. Leaderboard. Macy, Britannia, always wrong. It's not always wrong. And our main winner is Macy. Second is Britannia, and third is Siva. Please reach out to Jack. We do have swag for you.
Awesome.
Okay, and even with me no sharing screen, we will make it. Okay. Closing. All right.
We have an Astrakathon.
Yeah, so can you share? Yeah.
So
that would be nice. That would be nice.
All right, one moment here. We're going to try something so we can actually get you all the current info.
Yeah. And so remember, after the 2-hour session, we're almost done, 5 minutes, no more. We are running, 5-minute break, and we are doing Ask Me Anything question for 20, 30 minutes altogether. I won't share my screen, so it should go smoothly.
Just your screen, that's the problem there, Cedric.
Yeah, so let me stop sharing. Not sharing anymore.
Yeah, so we've already seen a couple submissions actually for the Astrakathon.
Yeah, but today is the last day of Astrakathon. So 12 p.m. PST is the last is the deadline to submit Astrakathon submission. So it does not to be a huge application. We wanted to just see how much data model you can do and the small services on top of it, providing a README for us to do it, to read it.
Right. And for those of you who have something that isn't quite completed, submit it anyway. We're not going to extend the deadline just due to kind of constraints around the actual Astrakathon, but we do want to see, even if you have a partial app, love to see things. If you have a data model built out, if you have the app idea, just try to make sure everything's documented enough that we can kind of tell what's going on. And don't want you to not submit just because you aren't quite finished.
Exactly.
All right. Alex, how are we looking?
62.
All right. And in one moment here, we should have it.
Okay, take a question on YouTube.
Yeah, let's see what questions are out there. International Space Station talk. Love it.
Top 3 email, yeah, Jack. Frozen, yeah. Win some swag, question.
Not a lot of questions on the actual content. You must have been presenting quite well.
Yeah. Because we still have 400 people watching with us.
Absolutely. Oh, look, to my earlier question about ports, Kubernetes control plane allocates a port from a range. So it's basically a reserved port range. Interesting. Okay, so I learned something today. That's awesome.
All right. Okay. So yeah, we say that already. So deadline for our hackathon is tonight. We won't expand. Submit even if you don't have a finalized application. We really want to know how much you went through. And so today indeed is the last workshop of the series, 8/8. But you probably still have a lot of questions. So we are doing a 30-minute Ask Me Anything question right now. But next week, we will bring all the members of the team, so 6 heads, we will call that the Hydra episode. And we will all there, including Jack Fryers, on screen to answer any of your questions. So stay tuned. We will put the live schedule as usual next Wednesday, just for a special Ask Me, Ask You Anything question with much more swag to win and more Menti meter. It's need to be
the after party.
Yes, it's need to be a fun after party.
Real quick question in chat here. Can we show the demo then? I think we probably could show the completed demo in GKE unless there's an issue with that. Just kind of here's it running, here's the completion, just because we didn't get to see it today. I think that would be totally doable.
One more thing. Don't forget what we have second run of this workshop tomorrow. So maybe for some of you it also may be handy.
Yes, excellent. That's very true.
And every session is recorded, so you can totally go only to the demo part. But that's really me typing the command, to create the resources in GKE and show the UI in the end. I think the most important was also to see step by step using the slides which resource have been created and why.
Absolutely. All right, do you want to take 5 minutes here?
Okay, so next, can you just next slide? I think I do have one more slide.
Oh, one more. All right.
Back to the voucher, and we will do okay because I'm not sure that everybody was there at the beginning of the session. So for the voucher, they will be issued early next week. You will receive an email with a link to claim your certification voucher. You must complete the form if you would like to receive the voucher. So remember, the voucher will be sent next week.
Awesome.
And yeah, with that, we've completed the series. Congratulations to have made it to the end. And we take 2 or 3 minute break to take some water. We are already late and go back for question.
Yep. So starting in about 15 after the hour, we'll be here answering all your questions. All right.
I'm okay. I will stay there here anyway. But I cannot see the question, so I must be. So why should I do? I should go to Discord. Try to go to Discord. No, that's okay. That's okay. There is no secret. There is no secret. And yeah, people show a few seconds of the slide saying that in 2 weeks we will do a dry run of Cassandra certification as a workshop. But that will also be part of the email.
Yeah. Are we audio live?
I think we are.
We are? Okay, cool. Perfect. Thank you. Was a rough one, but we got through it. Man, it's such a cool thing to get through 8 weeks of content like this.
I don't know what did Skype today. In the end, right in the end.
Yeah. It's all good though. The team here being able to pull this off at basically the drop of a hat was just incredible. Especially at the quality level.
It was a lot. It was a lot to cover.
Yeah. Yeah, for sure.
We do have really good and nice comment coming on Discord now. Thank you. But you know what? The recordings, the slides, the GitHub repo won't go anywhere.
All right, I better get Discord pulled up here so I can see what people are asking in there. Hopefully my laptop doesn't freak out with audio. Sometimes when I open Discord, it tries to do a mic switch thing.
Totally hear your fans screaming.
Can you? Here, I'll move my microphone slightly further away from the. How's that? Can you still hear me all right?
I do. So what do we say? 1 more minute because we were a bit late, and let's start.
Yeah, about 1
If we do have a question.
Oh yeah, we're starting to get a couple here. All right, so let's look at the top here. All right, so I think we're good to go. Thumbs up or?
Okay, so first question is for the Astra Hackathon, pretty easy. So yeah, the Astra Hackathon deadline is indeed August 20th, so today, at 12 PDT, so tonight. Let's say how many times, it's 12 hours left, something like that.
So we got a question on the Docker, how to push an image to the Docker repository. We did touch on this briefly, but I'll let Cedric answer that one again. It's pretty simple here.
Yeah, so first you go to hub.docker.com. I'm not sharing my screen, you know why today. But you go to hub.docker.com, you create an account, user, password, then you will have your own space on hub.docker.com. Okay, then on the Docker command on your laptop, you can do Docker login and provide user password. It will simply say, I have connected you to the Docker hub, okay? And now, locally, you do have a Docker registry. If you type Docker images, you see all the images that are available for you. So there are the public images, but also one that you have built. You do. Remember, we did that 2 weeks ago. We did Docker build, providing a Docker file that created a Docker images. If you run Docker images, it's there. Once you are there, it's mostly one command. You simply do Docker push the name of the image, the tag, and it will start uploading your image to your space. But be aware that I think the prefix of the image should match the name of your space in Docker Hub.
Cedric? Hello everyone, that's Alex. I was with you all the workshop behind the sound, behind the stand, let's say. So if you want, I can show it briefly right now. And actually there are 3 nice things to show. So do we have any more important questions, or I can show it?
We are getting a number of questions here. So maybe if we have a little bit of extra time at the end, but we can do an example, but I do think we probably are going to have enough questions to fill the time.
Keep going for the question, but thanks for proposing.
So real quick here, can we test in AWS, also including GCP? I'm not exactly sure on the wording. I'm wondering if the question is, can we run this in AWS as well as GCP? The answer would be yes. Obviously, we showed earlier that AWS does have a container service, a Kubernetes service. You can go through and do all of the same steps, but in the AWS way of doing those steps, and use that image from Docker Hub, just like we did with the GKE.
Yes, so in AWS, you do have the EKS service, so Elastic Kubernetes Services, where you can create a cluster as well. You can create config map, pods, deploy the pod. Remember, it's still kubectl apply, okay, working the same. But when it comes to exposing the port to outside, node port would work the same. But the firewall, it's not the same. You have to work with security group, so it's not 100% the same.
All right. We have, in the gossip process, how does the node select which node it communicates with? Ooh, we're getting deep down into that there. So if I understand the question correctly, that's determined by the snitch, which is kind of a whole nother topic. I don't know if we're going to get into that here in detail, but essentially the gossiping, I'm trying to think of how to best describe this in less than 10 minutes. Probably a question for another time, in all honesty. But essentially, if you want to do some reading on it, you want to look up some docs on it, I would Google Cassandra snitch and kind of read how those work and what those are actually doing. Gossiping property file snitch is basically the one that you will be using in 99% of your production use cases. I don't really think there's a reason to use another one, at least not a good reason. What else we got here? Some cert questions. It looks like Jack is kind of grabbing those as they come, so keep an eye on chat for those.
I see a question about ECS and EKS, all about acronyms. So those 2 services are on AWS. The first is Elastic Containers Services. So it will run only your Docker containers, or even maybe containerd. It's kind of the same as Docker Compose. It's really start, stop the container, that's it. Whereas in EKS, it's a full Kubernetes cluster when you can not only run the containers, but orchestrate the container and use deployment that will manage a state you expect from the system. So ECS Docker, EKS Kubernetes.
Awesome. When will the presentation be uploaded to GitHub for this session? When are we doing that? I think we already have the links in there, don't we?
No, the PDF is not there, but
PDF isn't there yet.
should be today or tomorrow at most. Ping us on Discord if it's not the case. But
Yeah,
I got that. The presentation is nice. I will give you the PDF. How many hours did you spend putting the all nice icon to show you that architecture diagram? Anyway.
All right, we have, if I create a new key space, how do I know how many nodes are associated with it? I'm assuming you're talking about Astra. So that is actually determined by your data center replication. So if I create a key space within a data center, actually this is true of all Cassandra, and I have 6 nodes in that data center, then it will be associated with 6 nodes. Now, if I had multiple data centers and I associated that using a replication factor, the network topology strategy, and then a replication factor that was, say, 3 in both of my data centers, if both of those had 6 nodes in each data center, then obviously 12 nodes would have some association with that key space. So it's kind of just a simple math problem, understanding what replication factor is, what your data centers are, and how those work. You can determine that. Technical Cassandra question. Why is select star an anti-pattern in Cassandra? From a performance perspective.
Really?
Okay.
we are workshop number 8.
I'm gonna get on my soapbox for 2 seconds. It's a good question. So everyone does need to hear this. So even in a large relational database, what happens if you write select star and hit from a table and you hit enter? Your your DBA calls you angry, asking why you're bombing his database. When you do that same thing with Cassandra, now we also have a network layer because we're distributed, right? So essentially, you get a call from a very angry DBA saying, why are you bombing my database? It's an anti-pattern across the board. It's just in Cassandra, it has an even bigger impact because of the network in the middle there. That's probably the best way I can describe it in a short fashion. Basically, don't do it. Don't do it anymore.
If you don't provide a where clause, then you are doing a full scan cluster. So all the nodes will work and provide answer. If you have 1,000 nodes and only one have the answer, that will use a lot of carbon for nothing.
Right. And if you have a petabyte of data, you have to scan a petabyte of data. Like, that'll just time out. You'd have to take a lot of timeout protection off to even complete that query successfully. So, yeah, just don't do that. All right. Oh, wow. This is scrolling fast. Man, Jack is on point today. He's just getting all these questions answered.
Yeah, so on Discord, I do have here something like, can I create new key space in Astra because I already have killer video? So no on the free tier, as far as I know. So the features exist, but it has not been GA for everyone. So for now, on the free tier, no. But if you are using any of the enterprise tiers, yes, of course you can. I don't know if it's coming for anyone. I should add this question internally.
Can we talk a little bit about seed nodes? Looks like Bettina is asking, what is the question about seed nodes? Yeah, if you have a specific question about them, what they are, how they work or something, please feel free to ask. Would totally be willing to clarify something there. Let's see here. Yes, but the question was when you do a where clause, okay, to the select star. So if you have bound it with a where clause, there's no reason not to do a select star if you want the whole row back.
The anti-pattern is no where clause. It's not really select star.
Right. Select star is completely fine as long as there are.
But that may be my. I tend to say select star is not a good pattern. That's me. No
right, select
where
what
clause.
you want, right?
Yeah, you select any column you like, but no where clause is the issue.
Yeah, absolutely. Let's see here. We've got A lot of thank yous for the training. Thank you, Al, for attending. We don't get to do these unless people show up and are actually participating. So thank you for making my job awesome.
We appreciate all the feedback. Yeah, that's a lot of work. So that's very nice to have all this. Thank you.
Okay, so what is a seed node? How do we define it? Is the clarification on that? That's actually a really good question. So in Cassandra, if we're just talking, I'm getting the tarball, putting it on a box, configuring, spinning it up. In the Cassandra.yaml, there's a little seed node parameter in there, and you can actually designate which nodes are your seed node. And so that's how you define them. What is it? Well, it is basically the node that you're going to point either your driver or a joining node to and say, that person knows what's up, that person knows what the topology is, talk to them first. The reason we do that is so that you don't end up with a split brain where half the nodes know about each other and the other half know about each other, but no one understands about the entire topology that's there. So it basically prevents that split brain problem because it forces everyone to have to go and talk to a seed node when they join. Beyond that, there's nothing special. There's not, like a master, kind of architecture going on there. It's nothing like that. It's just a place that's going to guarantee a correct topology understanding for the new joining nodes or the incoming driver connections. Basically anything that's going to participate in gossip. All right. Let's see here.
Can we talk a little bit about seed nodes? Yeah, that's seed nodes is just a static list of IP you provide when you bootstrap a node, because those nodes tends to have the best topology or the topology more accurate. But yeah.
Is it possible to write and deploy scripts that prevent such select star queries from running in production? So basically a safety against someone doing a full table scan. That's actually a really good question. I don't think there's anything in place at the moment. Are you aware of anything, Cedric?
No, there is no guardrails in too many results bringing back.
There's been discussion for ages within the community around whether or not those should be provided or some guardrails there. Definitely something. If you have strong opinions on that, reach out to the community, make your voice heard for sure.
Yeah, but afterward you can easily spot queries with no where clause because they will take edges and they will immediately be slow queries.
Right. Very true. All right. Let's see here.
Seed nodes have any other usage than bootstrapping? Not really.
Not really.
It's not a master or anything. That's just something with a static name, easy for a node when it bootstrap to find his buddy and get the topology.
Yeah. How does garbage collection work in Cassandra? I assume you're talking about JVM garbage collection.
Oh, wow.
That's another topic I'm not going to be able to answer in a 10-minute window, but the simple 2-second is it's Java process. It works just like any other Java process. You define your garbage collector and the parameters, and it does what it does. Sorry, I can't go anymore.
But on the same YouTube channel now we do have the all DataStax Academy courses available here on the YouTube channel. So if you go to DS210, there is a dedicated video on tuning GVM for Cassandra, and also I think there is a very good talk from John Haddad about tuning 10 lessons learned to tune Cassandra JVM, and he actually told his parameter XMX, XMS, hit ratio, how many memory depending on the size of the node and the query, and also which garbage collector. Should we use CMS or G1 depending on the workload you have?
Available resources.
Yes, and it's a bit too soon for playing with the GC and GDK 11 garbage collecting. It's part of. You can do that with Cassandra 4.0, but it's too soon to give use.
Oh, Interesting.
fine-tuning.
So I'm learning another thing here. Patrick McFadden in Discord there actually has
Everybody on
info
Discord.
on the
Ping Patrick.
guardrails.
Hi, Patrick.
Yeah, say hi to Patrick. He actually has a info on the guardrails there. There's actually a ticket in Confluence. So if anyone's curious, feel free to check that out. I did not know that one existed, actually. Looks like it was made back in May. So that is awesome. Very, very cool. Okay, had another question here. So is it okay to have a dead node in the seeds? I assume like a dead seed node in your cluster. You would want to address
That's a lot of questions from seed node. Same in Discord. You know, how many seed node per DC? You know, how many? You know.
From a perspective of will your cluster stop returning data if a seed node is down? The answer is simply no. And you use quorum, use best practices, and you're not going to go down from a single failure. But you do need to address that. Why did the node go down? Did you need to maybe remove that node, replace it, or are we talking about something where a process just died and you need to fix it? Did a data drive get filled? I mean, you got to do all your standard troubleshooting with that node and make sure that it's up in a healthy state. But just flip it back on and you should be basically good to go. Let's see. It's always a good idea to have up nodes only. I mean, yeah, absolutely. Failing nodes, we don't like failures, right? Okay, let's see. How will nodes adjust the data when the RF was changed? Ooh, that's a good one. Okay. So if, for example, I'm changing the RF from 2 to 3, basically it'll cause a streaming operation. And that streaming operation goes and rebalances data. Now, there's a couple of things you're probably going to want to do after that streaming operation takes place. Node tool cleanup and a repair being two that you should definitely read up on. Basically, what that's going to do is make sure all the data is where it's supposed to be and that data is not where it's not supposed to be there. Respectively. So definitely, if you're planning on doing that sort of an operation, I highly recommend going into the docs and understanding exactly what's going on there. But on a simple kind of 30,000 foot view, that's kind of the what happens there. Let's see here.
Yeah, just looking at that.
Seed nodes defined, yeah, 2 per DC, absolutely. I would feel totally fine saying 3 per DC if you have 6 or more nodes, not a problem there. Seed replication work.
Yes, so very nice feedback from try on Discord. Thank you, DataStax team, for the series. The second half, 5.8, is the best part to me, not only Cassandra, but also general background about cloud ecosystem. Yeah, this is also why the name of the series was Cassandra Cloud Native. The idea was first to make you discover what you can do with Cassandra and why it's really a good fit for any future cloud-oriented architectures, because it's scale out, it's working quite the same, working well in Kubernetes and everything we told up till now.
Yeah, so Patrick is posting all sorts of stuff. There's even a CEP to do joins in Cassandra. No.
Don't feed the monster now. Patrick will give you the line code in Cassandra code.
Oh my goodness!
Look at the code in Cassandra. Here it is.
It's encouraging people to stab themselves in the foot, is what that does. Okay, moving on from that.
Okay, so let's see. A couple of questions.
Here's an interesting one on YouTube. I can see that without back-end full table scan prevention, Cassandra would be vulnerable to a kind of SQL injection hack, right? I assume it's hack is kind of the other word there. Yeah, that's actually a really, really interesting aspect. There is SQL injection. It does exist. There's still best practices around how to structure your queries, how to code, how to do all this to prevent injection. Just like in SQL, how you can do a SQL injection attack, that same concept does exist in the SQL or Cassandra query language. So yeah, good call there. Absolutely correct. Use best practices. Don't let people submit their own queries through an input box. Don't do it. Not good. Let's see here. Tell us more about what's in the pipeline later for the year. Right now, we are actually still figuring out some of that. A lot of it has to do with what people are asking for and what people are looking for. Kind of with this whole COVID thing when it hit, we've had to restructure all of our content from in-person to now kind of this more remote structure. So we are actually producing this almost up until the day that we're releasing. So if you guys have stuff out there that you really want to know, let us know. Go onto community, hit us up on Discord, and we'll take those and try to create content and sessions around that. If there's obviously enough interest, for sure.
Yeah, maybe one. So next week is the Hydra episode. Okay, it's for granted. In 2 weeks, because everybody's working on Cassandra certification, we are trying to organize, dry run for Cassandra certification. So maybe the session will be called "Everything You Need to Know to Get Cassandra Certification," about the process, how to register, what's happened during the session, what you need to have ready, your ID, using the camera, all the setup. And we may do a dry run, 60 questions. Maybe not 90 minutes or 90 minutes, but we tend to explain a little bit the solution. That would be a good one, I think, for beginning of September.
Absolutely.
Later on, let's see. We will review all the feedbacks we have from you from the MENTI, just to have something good for you. I think on September 16, we committed for Cassandra and Kafka with our partner Anand. We did a first session with them in June, so let's do part 2. Cassandra and Kafka.
Absolutely. Okay, got a couple more here, and then we're going to have to wrap it up. We're just almost at time here. Here's a good one. Can we deploy any type of application in the cloud? Are there limitations on that, particularly on legacy systems? So if you think about it, all the cloud is, especially if we're talking infrastructure as a service, that kind of portion of it, all it is another computer somewhere. It's running your code on that other computer. So, as long as there aren't on-prem requirements to your application, or it's not a giant mainframe sitting in your basement, absolutely. There's the limitations are what you can run on that version of Ubuntu or Red Hat or whatever the base OS is. And actually, one thing. On the mainframe point, a lot of companies actually are doing migration efforts from mainframe to more cloud type boxes, and they're using tools like Apache Spark and a lot of other analytics tools out there to accomplish that. There's some really interesting stuff in that space, but that's a huge topic, something we definitely don't have time to dig into right at the moment. And then I think one more. You see a good one, Cedric?
I do have a question on compaction, but Patrick was on it. A few questions on the certification again. So that will be part of the episode, but to pass the developer certification, it's recommended to take DS210 and nothing. So developer certification, DS201 and DS220. And if you also want the certification, the admin certification, you need to add the S210 on top of it.
Absolutely. All right. Well, I think that's probably going to wrap it up for today.
Sure.
It's right at the 30-minute mark pretty much. So thank you guys all for coming out. Again, we get to do these things for our job because you guys show up. So it really does mean a lot to us as the developer advocates here.
We are still more than almost 300 on YouTube. That's amazing to have you until now. And thank you very much to have been there for us for the full series. And again, we are still there on community and Discord for you. Thank you very much.
And we will see you later.